Hey guys, my name is Stuart, and today we're going to be having a look at how to build this alarm circuit that is activated by a magnet. Let's have a look at what we've got inside. Okay, just double check that you've got two pieces of cardboard, your cover page, some jump wires that have been cut in half, the colors of a rainbow. You'll have a little, this is our cell holder that we're going to use to get our cell over here to connect with the rest of our circuit. You've got a strip of curious gum, you've got a roll of thread, you've got a long piece of wrapping wire, and a small bag of small electronics components. So inside your little bag of electronics components, you'll have these bits and pieces. The battery will be separate, but I've included this over here. It's actually a cell, it's not a battery. So to start with, you've got this super cool neodymium magnet. This is a very powerful small magnet made out of rare earth metals. Then you've got a reed switch. A reed switch is a switch that turns on in a magnetic field. So you can see that these are related. And we're going to use the magnet to turn our circuit on and set off our alarm. Then you've got an LED. An LED stands for light emitting diode, and a diode is like a one-way valve for electricity. So you need to remember that it is a polarized component. That means that the long leg is positive and the short leg is negative. And if you wire this up the wrong way around, it won't turn on. Then you'll find that we've got a little piezoelectric buzzer. And this is also a polarized component. So its longer leg is the positive, the short leg is the negative. And if you cut the legs and you're not sure which one is which, there you've got the little positive symbol for you. It's also got a sticker on it, and it says remove seal after washing. That basically means that when they use these in production, if they're building this into a computer circuit or something, they often wash the circuit boards with alcohol after they've soldered it to get rid of the flux. And this is just to prevent the solution from getting inside and damaging the component. So you can peel that off straight away. Then you've got a little push button. A push button is turns on when you press the button, so it's a normally open switch, and when you press it, it closes and allows current to flow between the components, the legs. And this is not polarized, so it doesn't matter which way you plug this in, electricity will flow in either direction. The last component that you've got is quite an interesting one, and I'm not going to go into too much detail on this, but basically this is a thyristor, or a silicon controlled rectifier, and it is a semiconductor device. It's a combination of a PNP transistor and an NPN transistor, and if you don't know what those are, that's not a problem. But basically it's like an electronic switch, but once you turn the switch on, it stays on. So if its switch conducts electricity from the one leg, which is called the cathode, to the other leg, which is called the anode, and the middle leg is what they call the gate. And if you put an electrical signal, if you apply a current to the middle leg, the gate, it opens the gate, and then the gate locks open. So it starts letting electricity run through it, and it is on until the power source is turned off, or you somehow interrupt the current flowing through, and then the gate closes, and then in this case the alarm will turn off. So we use this component in our alarm circuit to prevent somebody from setting the alarm off and then easily being able to turn the alarm off again by closing the door or whatever. We want the alarm, once it's triggered, to stay on until we reset the alarm. We don't want our criminals to be able to turn off the alarm when they set it off and then still get away with stealing our stuff. The other electronic component that you've got is not really an electronic component, it's just a series of wires, but these wires have a little socket attached to the end, and these sockets allow us to plug components in and not have to solder them together in order for them to conduct electricity nicely. These peel off if you just grab it and you pull it off like that, they come off. They're just manufactured like this in one bunch in a process called co-extrusion. Each separate color is extruded at the same time, and so they melt together as it comes out. It's really cool. So for us to be able to use these, we need to expose the wire underneath this insulation. And there's a number of ways you can do this. The easiest way is to use a pair of scissors, and you're going to open your scissors. You want to strip around 1.5 to 2 centimeters of the insulation off this end so that we can wrap it and twist it into other things. So you're just going to take your scissors and very carefully, slowly cut all the way around. You're just going to cut the plastic off on the outer layer. You can twist it around until you've cut through the outer layer of the insulation, and then you can just grab it, twist it a little bit, and then pull, and there you can see now we've exposed the copper wires underneath. Now there's individual little strands, so it makes it easiest to work with if you just hold the one side and twist it so that the strands get twisted together and it sort of forms more or less a solid wire. Okay, so start off, first step is to strip all of these wires so that you've got about 1.5 centimeters of your wire exposed. So while we're busy stripping wires, we're also going to want to strip this wire. This wire is a little bit different. This has just got a single strand of wire on the inside, and it's really, really thin and easy to break. But the insulation on the outside is also very thin and easy to break, and I find it's easiest to prevent it from being damaged. You can actually just, if you've got nails, like I did with those ones, because I don't like to use the scissors, you can strip a section of the insulation off like that. We're going to go about 2 or 3 centimeters of wire on this one, but before we do that, we're going to cut this wire into 4 strips of about 20 to 25 centimeters. So I'm going to measure from that side of the board to 25 over there, and use my scissors to just trim that wire. So we're going to do 4 of these, and then strip the edge, either end of the wire there and on this side, at about 2 to 3 centimeters of insulation to strip off. Remember, this wire snaps very easily, so work gently with this. Alright, if you make a mistake with that, we've given you more wire than you need, so you can make a couple of extra ones if you need to. Otherwise, you can save this for another project or for modifying your project at a later stage. So we've got 4 strands of 25 centimeters, 20 to 25 centimeters long, with 2 to 3 centimeters of wire stripped on either end, and all 10 of these stripped. You're only going to need to use 9 of them, so if you make a mistake with one of these, you've got a spare as well. Cool, so from here we're ready to start building our circuit, but we need to have an idea of what the circuit's going to look like and how to build it. And we're going to go first and draw a diagram of the circuit, and on top of that we'll also draw the layout of the components of our circuit board before we start. Okay, so here's what our circuit diagram looks like, and what we're going to do quickly is go through how the circuit's going to work and what components are what over here, and then we'll move from this circuit diagram to the circuit board layout diagram, and then we'll start building. So to start with, we'll go from the power source. We've got a 3-volt cell. Now the reason it's called a cell is because there's just one of them, so it's not a battery. A battery is a collection of cells. So we've got our 3-volt cell sitting over there. It's a good idea to not eat these. Next we've got our buzzer, and the buzzer goes over there. Our LED goes over there. Our reset button goes over there, and our read switch sits up at the top there, and our thyristor sits over there. So there you can see all the different components. Let's see what's happening here. So the electricity starts and it's going from positive and it branches out into three different directions. The fourth is the wire going from the battery. So it comes out from the cell and it branches off over here, and we'll go down this way first. So we'll see the electricity runs down and it goes to the thyristor, and this is what they call the cathode. So the electricity can't flow through this component until it gets turned on by the gate over here. So that's the little middle leg. So you can see we've also got this section of the positive coming through to the reed switch. And we know that with a reed switch, when the reed switch is turned on by a magnet, when the reed switch goes into a magnetic field, it gets turned on. So electricity can conduct and goes to the gate. Then this thyristor turns on and electricity can conduct through this. So this is going to be attached to our alarm sensor door or something. So this is the sensor, this is the door. If the door passes the sensor, it turns this on, and then current can flow through the thyristor. As soon as current flows through the thyristor, it comes to another branch, and first it goes up to the buzzer, goes through the buzzer, and then all the way around back to the negative. So we've got a complete circuit there, but it's wired in parallel with an LED. So the electricity goes down both paths at the same time, and it'll drop down here, it'll go through the LED and also complete the circuit and go back to the negative on our cell. So we've got the electricity coming through. If it first gets turned on by the reed switch, then it turns the thyristor on, but then the thyristor stays on. So if you carry on putting your magnet up and down on the reed switch, it's not going to do anything because this is already turned on, and it'll keep the alarm going. So our light will be on and our buzzer will be buzzing, and that circuit's going to continue in that state forever, or until the battery runs flat, the cell runs flat, because it's very, very difficult to turn a thyristor off. And that's where the reset button comes in. Now, electricity is lazy, so if it can find an easier path to travel from the one side to the other, it'll take that path. And the reset button has a lower resistance to the flow of electricity than the thyristor. And you can see that the reset button is also wired in parallel to the thyristor. So when the electricity is flowing through the thyristor and we press the reset button, suddenly it says, oh, I can go this way instead. And it goes through and it still turns the buzzer and the LED on, so we can use our reset button as a test button as well to check that our battery is still working and that our buzzer and our LED are working properly. But it also is, if you press the button, it bypasses the current, stops flowing through there and says, oh, I can go this way more easily, and then it goes through those and comes back. So when we press the reset button, momentarily the current stops flowing through here and the gate closes, and then it needs to have another magnetic field on this side to reopen that gate and allow it to continue going through there. So when we press the reset button, the alarm will carry on going, and as soon as we let that reset button go, then the entire circuit is reset, because this gate closes, and as soon as you let this go, then there's no way for the electricity to continue traveling from this side of the circuit to this side of the circuit. I hope that makes sense. So the circuit diagram shows us what the components are doing and what the electricity is doing in the circuit, but this is not what it's really going to look like physically. So let's have a look at the physical board layout of our circuit now. At this point, if you feel like you're capable of taking this circuit diagram and building your complete circuit, if you feel like you're technically inclined enough to be able to do that, you can go ahead and straight away start looking at how you're going to design the board layout. But this is an example of what it looks like. This is one of the earlier prototypes that we were using. And so here's our magnet. These are all the components laid out physically. So you can see here is our reset button, here's our buzzer, there's the thyristor, there's the LED, there's our cell, and there's the reed switch. So if I take my magnet and I put it over the reed switch, you can see the alarm goes off, and press the reset button, it switches the entire alarm off. If I press the reset button, it tests the system as well. You can see the LED goes off, and so does the buzzer. Alright, so this is the working circuit. It's not beautiful, but if you want to go ahead and design it yourself like this, you can do that. If you think that you can do it better, go for it. But that's what we're going to be building. So let's see if we can make it a little bit neater and easier to follow what's going on than this. So here's what we've got in terms of the physical layout and how we're going to wrap the wires. It's not as pretty as my previous diagram because I just drew this now by hand. So what we've got is we've got the push button over here, and we're going to use this wrapping wire that we've stripped, or use the ones that we've stripped already. And you can see that that's twisted onto the components over there. If you've got a soldering iron and you're capable of soldering, then you can solder all the joints as well. But we've designed this specifically so that you don't have to have a soldering iron at home to be able to make this project work. So we are going to have one of our wires coming on and joining onto the push button over here, going from our battery. Now our battery holder, I'll show you how to build that just now. We're going from the battery through to the first leg of the reed switch and to the cathode on the thyristor. From there, we've got the other side of the reset button going to this clump of wires. Now there are 4 wires joining together here, and those are the main positive wires on the other side of the thyristor. Right, so if we press the push button, the power goes from positive all the way through the switch, all the way across, and joins in over here and can go to the positive of the LED, through to the negative, all the way to the negative of the cell. The other parallel part of the circuit goes up positive to the buzzer, negative. You can see that both the positives and the negatives of these 2 components are joined together by twisted wires, and then this is going through to the negative. So the only way you can complete this circuit is by going through both of these components, because that's the only wire going to the negative on our cell. So if we have a look here, this is joined, all 3 wires are joined here. So positives going through, coming to the positive of our, or the cathode on our thyristor. We've got the positive going through to the gate, which is the middle leg, and then if this turns on, it goes from the positive through to the negative and joins in over here and then turns these on. So that's physically what this is going to look like. Let's move over now to how we're going to build this circuit. So step 1, physically building this, we're going to start with this cell holder that we've laser cut out of acrylic. We're going to grab our little cell and 2 of the 20 to 25 centimeter wires that we've stripped. Then what we're going to do is we're going to feed it through the one hole in the middle arm, other way through second one, and this is where we just want the strip part of the wire to go into the last section of the hole there and bend it flat. So when our battery presses up against this, it's going to just be pressed in contact with that wire running across there. That's all you need to do there. We're going to take the other wire and we're going to do the same, but we're going to start on the other side of this other arm. We're going to go through that hole there, get it out a little more, and bend it back. Right, so if we take our battery, slide it in. So there we've got contacts created on either side of our battery and holding it nice and firmly in place. Cool, so we're going to move on to step number 2. Right, so the next section of our circuit that we're going to make is the reed switch sensor part. Now this is going to be separate to the rest of our alarm because we don't necessarily want our alarm control unit sitting right by where we want the sensor to be. We want this to be relatively concealed so that people can't see that there's an alarm hooked up there. When you're working with this component, be very careful because this is made out of glass and it's very easy to break. So if you are bending the wires, support the wire a little bit away from the glass and then bend it gently like that. Fun fact, the color of this is because it's coated with real gold. Right, so we're going to take a section of your cardboard and a ruler. I'm going to measure around 2.5 centimeters. That's up to you. And we're going to cut off a section running across like this. You can use a pair of scissors, you can use whatever, but we're going to cut a strip of cardboard there, and then you can cut it in half to make it a bit smaller. Doesn't matter which side you use. Okay, next you're going to take 2 of your wires. So I'm going to take a gray and a blue wire, and I'm going to take my not cool. Stop waddling. Right, I'm going to take my reed switch and I'm going to bend the other leg as well so that both of them are sitting at an angle like that, 90 degrees to its body. Then I'm going to take the socket part of this, I'm going to slot it in onto each side of the wire, and I'm just going to push it in. You'll feel when it locates, it has a bit of a sort of like click to it almost, where it slots in. If it doesn't slot in immediately the first time, just twist it around a little bit. Okay, so we're going to take it like that, and we're going to use this piece of cardboard as the support to hold it in place. So we're going to slide each of these wires down the flutes of our board and slot it in each side, push it in nicely. Right, so now we've got a nice mount for our alarm sensor, and we can put this in various places so that when it moves past the magnet it sets the alarm off. Right, so we've got our stripped wires on the other side, we've got our battery holder, so that means we need to go from here to make the control unit part of our alarm kit. Okay, so for the main housing or body of our board, I'm going to give it a bit of a thicker piece of cardboard, so I'm going to measure it at 40 centimeters. Cut it along the marks that I've made. Okay, then I'm going to take the remainder of my wires. Remember, we've got one extra, so you can keep that as a spare. From here, we're going to start bringing in the components that we've got according to the diagram that we drew earlier on. And so I'm going to plug in, actually let's not use the black, let's use the black one for the negative and the red one for the positive on our buzzer. Okay, so we've got that threaded in, like we'll connect it up. We can take this, and this is the last one, and we want the positive to be on the outside. So can slot these in over there and over there. Right, see, holds it on quite nicely over there, and it's easy to kind of use that as a way of holding our components in place. So let's go from there to our next one, which will be our LED. We'll go with a purple and a yellow wire. So the purple one is going to the long leg, which is the positive. So we must remember purple is positive, yellow is negative on this. Okay, so we want the positive on the outside of this one, and we're going to slot those through those two holes, slide it all the way down, and then push the contacts in. That. Right, that's looking good. The next component that we're going to use is our thyristor, and that's got 3 legs, so we need 3 wires. When you take the thyristor and you look at it, if you look at it at the top, it's got a round side and a flat side. If you're looking at it from the flat side, this side is the positive cathode, this is the anode, and this is the gate in the middle. And if we get this wrong, then our model's not going to work. So I like to use orange to tell me that that's a signal pin. So I'm going to slot that into the middle one, and then we'll go with the brown as the positive and the white one as the negative. So we've slotted those all 3 together. I can take my board, and it doesn't have to slot exactly into any specific hole, as long as it helps us keep track of what's going on with our component here. Okay, so we've got a bunch of wires sticking out the bottom, which we'll start wiring up in a moment. The last component on our circuit diagram main board is the push button. And we're going to wire the push button. We don't necessarily want the reset button, certainly not by the sensor, where whoever sets the alarm off can just press the button to turn it off. So we could have it wired up over here, but it doesn't necessarily mean that the reset button has to be at the same point where the alarm is going off. So that's why we're going to wire it in using these 2 wires, and you can put it wherever you want. And to connect these up, we're going to take the legs. You can bend the legs out a little bit to make it easier to work with. You're going to hold a wire on next to it. You're going to take the strip part of your wire and twist it nice and tightly onto this leg, and that will give you a good enough contact to connect up your switch. So there you go. You can do that on both sides using both ends of the wire. Remember that the push button is not polarized, so we can do either wire either way around. Okay, if you want to thread it in onto the main board, you can do that. So I'm going to do that just so that it doesn't flop around. If you want to change it later, you can just unwind it and move it, but for now I'm just going to slide it in over here so that firstly it doesn't short out on the other components, and it's just neater this way for now. So we've got push button, our thyristor, our LED, and our buzzer. Now we need to start twisting these wires together, introducing our power supply and our switch. Right, so this is where it's really important for you to have your wiring diagram like this, because this shows you which wires you're going to twist together. So I'm actually going to just pull all of these components up on top here and work off this board so we can see how things are supposed to work. Now it can get quite confusing to wire all these wires up because there's lots of wires sticking all over the place. So we're going to do it in small sections. We're going to look at this one and twist these together as a start. So first of all, we know that the negative and the negative, so these 2 wires need to be joined together. So I'm going to take these 2 and I'm just going to twist them. You have to twist it quite a lot to get it to make a good contact, and you want these to make a nice strong contact, otherwise your thyristor might not work properly. Okay, so we've twisted those together, so you can see that already our LED and our buzzer, both the negative wires are joined together. We also know that both of the positive wires need to be joined together, so we're going to take the purple wire and the red wire and we're going to twist those together too. Now we don't want these to short out on each other, so when we finished wiring this up, we're going to connect the battery last so that we don't short anything, but when we are finished we're going to push these out of the way as best we can, and we're going to insulate it using our Curious gum that we've provided in the kit. Right, so what's next? We need to take, working from the right to the left, this wire over here, which is our white wire, needs to be connected to the positive 2 over there. So we're going to take this one and we're going to take this one, and again we're going to twist it. Keep twisting it in the same direction, otherwise you're going to unwind the ones and wind the other one on it. Okay, so there we've got our white wire, which is the anode of our thyristor, connected up. So that's this one joining those two over there. And the last one that we need to connect from this batch of wires here is the push button. You can see it coming from there. So that's this wire over here, and that's going to wind in onto these ones over here with the white, purple and red ones. So that's the one side of our reset button. So these ones are all joined together. That's ready to get insulated, but we're not going to insulate it until we make sure that this works. Right, next one, working from the right to the left, is the gate, and that needs to be connected to one of our reed switch connections. Remember, the reed switch is not polarized, so we can take the orange one, and orange and blue look cool together, so I'm going to twist those. Orange and blue wires together. That's going from the one side of our reed switch to the gate on our thyristor. Okay, so we've done that side, so we can look at this side. So now we've connected this up to over here. You can see it's looking pretty accurate. That's what the reed switch is looking like. So this side of the reed switch needs to then join to this side of our push button and to positive of our thyristor. We're going to connect those two together. That's this one and this one. Looks like one wire, but they're both wires joined. That's going to join like that. Then we're going to have the other side of our push button, and then the battery is going to connect with this 2, and the other side is going to go to the negative of our yellow and our black wires. Right, so I'm going to twist all of these together over here. Right, so that's this one and this one twisted together. That's the brown and the gray wires. We're going to take our loose switch wire and wire that in as well. Just twist it around. This wrapping wire wraps quite nicely. Right, so everything is now connected except for our battery. And so you take a look at the top here. This one, this flat side has got the plus on it. So this wire is the positive and the other one is the negative. So we're going to take this one, and if we look at our diagram, the positive of our battery connection goes and joins in on this one over here. So that was our brown and our gray wire. So I'm going to connect it over here and twist it up. Remember that as soon as you connect this battery, the circuit is live, so you don't want anything to short out or your battery is going to run flat very quickly and you're not going to be able to use your alarm. So make sure none of these wires are touching each other, because that will be bad. So now we're going to take our yellow and black wire, and we're going to connect it to the negative of our battery, and hopefully things will work and the alarm won't go crazy. Okay, so I'm going to be careful so that none of these wires are touching, and we can test to see if it's working by pressing our push button. Oh, my magnet over here is stopping this from working. So that's working. Let's see whether the reed switch side of things is working. So I've got my magnet and that's not working. So I've done something wrong. Let's see. Okay, so I've solved the problem, and the problem was that this SCR was plugged in the wrong way around. So I told you guys to plug it in that way around with the silver part pointing towards you. All you're going to do is unplug it, flip it around 180 degrees and plug it in there, and there exactly the way that you had it. So the middle wire is still in the same position, but the positive and the negative have just switched around. And if we take our wire, at least our magnet, and we put it over our reed switch, there we go. That's really loud. And there you have it. You've got a working circuit. So we're going to take our Curious gum now. That's this stuff over here, and you can pull off some bits of that. Doesn't need to be a massive blob. And we're going to use that to cover over the join that we've got over here, and I'm going to use that to just stick it down. So now these wires over here are not going to short on anything else, and we can do the same with these ones. You can stick them down over there, but I'm not going to do that because your project from here is, once you've got this working, is to now adapt this to a project of your own. So you're going to say, how am I going to make this work as a door alarm, so that if somebody opens my bedroom door, the alarm goes off and I can stop my siblings from sneaking into my room? Or am I going to try and work it as a bicycle alarm? How will I have to package it to use it as a bicycle alarm? And that's why we've given you extra bits of cardboard. So you've got another full sheet of this, and you've got this. You can package it, you can build it into your own housing. You've got more wire, so you can use this to take the battery further away, or if you want to mount the battery with the board, you can use the Curious gum and you can stick it on this side. Then you've got a neatly packaged unit. How are you going to make this useful? We've given you the design of the circuit itself. Getting it to work is great. Now, what are you going to use it for? I hope you've had fun building this project. Please send us pictures of what you built.